Hello everyone. In this video, we'll talk about 2025 AMC 12A number 19. So the problem says let A, B, C be the roots of this. What is the sum? So, what's interesting about the sum, right? It's got A cubes and like something to the third, something to the second for all terms. So where might we have seen this before? Well, I mean, like if it was like xy plus yz plus zx, it could be like x plus y plus z squared minus x squared minus like that. But there's a factor of like, but it's divided by two. So maybe we can do something similar here. And in fact, we can. So if we take, like we have a lot of cubes, we want to multiply by like, um, yeah. So there's a lot of cubes. So like we want an A cube, B cube, C cubed, and A squared, B squared, C squared. But when we multiply this out, we'll get terms like A to the fifth, and then plus like the cross terms. So, well, I mean, we can just subtract this. So let's call this T. The answer we want is simply this minus this. So the answer is also by Vieta's formulas, there's no x squared, so the sum of the roots is 0. The x term is k, so by Vieta's, like this is the sum of the roots taken two at a time is k. And we're also given like, I mean, we can use Vieta's again, anytime, like it doesn't hurt to list this out. Find the product. So, okay, we've worked forwards, we've worked backwards. So how can we get like a cube plus b cube plus c cube, right? Well, let p of x be this polynomial, x cubed plus kx plus 1. Let's plug in a into this and see what we get. So a is a root of the polynomial. So get this. And because it's a root, this equals 0. We can also plug in b and c. Ah, I see an a cubed, b cubed, and c cubed. So let's add these together. So we factor out the a plus b plus c from the like fourth, fifth, and sixth terms. But by Vieta's, this is just 0. So a cubed plus b cubed plus c cubed is -3. How can we get an a squared plus b squared plus c squared? Well, let's square this term. So let's square the first equation. A squared plus B squared plus C squared plus 2AB plus 2BC plus 2CA is 0. But we're told, I mean, Vietas also told us the sum of the roots taken 2 times is k. So this is just 2k. So a squared plus b squared plus c squared is just negative 2k. Okay, so this is negative 2k. Okay, so we have a cubed plus b cubed plus c cubed. It's negative 3. And we have a squared plus b squared plus c squared. How the heck are we going to get a to the 5th plus b to the 5th plus c to the 5th? Well, let's think back to what we did here, right? We got an a cubed, b cubed, c cubed. Maybe we can do something similar to get an a to the 5th. So let's multiply equation 1. Let's think. Let's multiply equation 1 by a squared. So this is a squared p to the a, p of a is a to the 5th plus ka cubed plus a squared is 0. We'll do something similar to 2 and 3, equation 2 and 3. So b squared times the second equation is b squared p of a plus b to the 5th plus kb cubed plus b squared 0. A. We'll multiply the third one by c squared. Well, now we can add. So a to the 5th plus b. So this is negative 3. This is negative 2k. So, and this is 0. So we get a cubed plus b cubed. I mean, a to the 5th plus b to the 5th plus c to the 5th is 5k. This is times k. So negative 3k, negative 2k equals 0. So yeah, this, so we have the sum of the 5th powers of the roots. So that means we have our answer. Our answer was this, t. So this is minus 5k. So I'll write this out separately. T is negative 3 times negative 2k minus 5k. So this is 6k minus 5k, which is just okay. Yeah. So notice how we nice. So notice how we moved forwards with Vietas and moved backwards by thinking like, how can I get an expression like the desired expression? And then, by seeing that we have a lot of a cubed, b cubed, c cubes, it makes sense to have one factor as a cubed plus b cubed plus c cubed. And then it also makes, because we have an a squared, b squared, c squared, it also makes sense to, like we have an a squared, b squared, and c squared. Like no, that's a squared, yeah. Then it makes sense to have an a squared plus b squared plus c squared term. So we tried multiplying out to see what happened. And then like this, we saw that we get basically what we want, but we have an extra a to the fifth plus b to the fifth plus c to the fifth. So then we gave a name to our polynomial x cubed plus xk plus 1, kx plus 1. And then we plugged in the roots into this equation. That gave us a cubed plus b cubed plus c cubed. We manipulated the Vieta-Swanius to get an expression for a squared plus b squared plus c squared in terms of k. And we like did something clever, like to get a to the fifth plus b to the fifth plus c to the fifth. So that gave us all the expressions we wanted, and then from there it was just a matter of computation.